Hi guys, so today we're going to be looking at final review part 3. So the first topic we're going to look at is simplifying exponents. So I'll give you time to try out the first problem, which is asking you to simplify 2x times 5x squared times y to the power 3 all to the power 2. Alright, so whenever we have a exponent on the outside of parentheses, the rule is that we have to distribute the 2 to every single variable and number that's inside of the parentheses. So that includes the y, the x, and the 5. So now my new expression is going to be parenthesis 2x times 5 to the power 2 times x to the power 2 to the power 2 times y to the power 3 to the power of 2. Then from there I can start dealing with the 5 to the power 2. I'm going to drop down the 2x. 5 to the power 2 equals to 25. And then whenever you have a power over a power, then we know that the rule is that the exponents will be multiplying with each other. Or instead of using that multiplication sign, I'm going to use the dot multiplication sign. And then we have here y to the power 3 times 2. From there, now I have 2x times 25 times x to the power of, that changes into x to the power 4, and this will turn into y to the power 6. I'm going to drop everything else down. So we have here 2 that's multiplying with x times 25 times everything else. And then I see here that I can multiply 2 and the 25 together. So I'm just going to switch around the x and the 25 with each other. So that we have here 2 times 25 times x to the power 4 times y to the power 6. 2 times 25 equals to 50. And then we have the same variables multiplying with each other, which means that our exponents are going to add. So we have an imaginary 1 right here, which means that we get x to the power of 1 plus 4 times y to the power 6. And so now I have 50 times x to the power 5 times y to the power 6 as my answer. And then I'm just going to get rid of those multiplication signs so that we can get our final answer here. Okay. The next problem is asking us to simplify 8x to the power 6 to the power, or y times y to the power 2 divided by 12x to the power of 4 times y to the power of 8. So before I do anything, easiest way to deal with this is to separate everything with a multiplication sign. When I separate it, I can see what I can combine together a little bit easier. So right here, I can look at the 8 and the 12. From there, since we have 8 and 12, I could divide both of them by 4. If I divide 8 by 4, I get 2. And then if I divide 12 divided by 4, that equals to 3. And then after I do that, I can combine the x's together. So if we have variables that are dividing by each other, that means that the exponents are going to subtract. Now, since x to the power 6, which is on top of the fraction, is the bigger exponent, that means that we're going to be subtracting on the top of our fraction. So we get here x to the power of 6 minus 4. The next one that we have here is y to the power 2 dividing with y to the power of 8. So from here, I'm going to subtract on the bottom because of the fact that the 8 is bigger on the bottom of the fraction. So we get here y to the power of 8 minus 2. And so altogether we have the 2 and the 3. X to the power of 6 minus 4 is x to the power 2, and y to the power of 8 minus 2 is equal to 8y to the power of 6. That would be my final answer. Cool. Alright, I'm going to clear my slide and let's continue on to the next one. It's asking us for radicals. So try out the first one on your own. It's asking you to simplify the square root of 120. Give you a few minutes to try that out on your own first. Alright, so simplifying square root of 120. We have here a big number, so that means that the best way to find out what all the prime numbers are in the radical is by using the factor tree. So 120, I could use 12 and 10. Those two would multiply to get 120. And then for 12, we have 3 times 4. 4, we have 2 times 2. 10 is 2 times 5. After we do that, we just need to identify all the prime numbers. So if I want to find all the prime numbers, easiest way to do that is by looking at the endpoints of the fractions. For example, 3. 3 doesn't have another additional 2 numbers that can multiply to get 3. It's just 3 times 1 and that's it. So that would be called a prime number. Another one is 2. That would be a prime number. There's no other numbers that can multiply to get 2 other than 1. And then also 5. Once I identify all my prime numbers, I'm going to list them out in my radical here. So we have 2 times 2 times 2 times 3 times 5. And based off of that, the only pair that I see here is that 1, 2. So because of that, we're going to take out that pair of 2's from the radical. Whatever is left over just stays inside. The 2, the 3, and the 5. Cool. And so then from there, I'm just going to multiply 2 times 3 times 5, which equals to, let's see, I think that would be 30. And then we just drop down the 2. And so that would be my final answer. The next question is asking, the square root 76 is between which pair of consecutive integers? So this one is asking you to guess where the square root of 76 would be between. So the best way to do this is to kind of guess it. Let's say that we have here 5. Let's see if it's between 5 and 6. If I want to see if it's between the numbers 5 and 6, then I'm going to start off with trying out to see what the 5 would turn into if we had it as a square root. So right here, if we had 5, that means I have double 5 times 5 in the square root. And so that would be the square root of 25. Square root of 25 equals to 5. Let's look at 6. If I saw 6 here, that would be the square root of 6 times 6, and that would turn into the square root of 36. We still need a bigger number, so let's try out 7, because square root of 76 is not in between these two. Square root of 7 is 7 times 7, that would equal to square root of 49. And then if we had 8, that would turn into square root of 8 times 8, which would be square root of 64. We're getting a little bit bigger. Let's try out 9. If we had 9, we have square root of 9 times 9. That would equal to the square root of 81. So square root of 76 is between square root of 81 and square root of 64. So the numbers that 76 is between is 8 and 9. So we could say here square root 76 is between 8 and 9. Okay. Cool. Let me clear it. Okay. And the last one is the Pythagorean theorem. So in this case, that we're given a diagram of a right triangle, and it's telling us the given points of A and C, and it's telling us that we need to find out what B is. So the formula of a Pythagorean theorem, the main idea that you want to see here is that the formula is leg being squared plus another leg being squared equaling to the hypotenuse squared. Now the first thing you want to do is identify what the hypotenuse is. And the hypotenuse is always going to be the side that's opposite of the right angle. So if you can see here, these two sides are creating the right angle. The only side that isn't is the opposite side, which is the hypotenuse. So we call C here the hypotenuse. Since C is our hypotenuse, that means that A is our leg and B is going to be our other leg. So from here, I can just plug in some of the numbers first. So we said here that A is equal to 2, and we said that C is equal to 10. So that means that one of our legs is going to be 2. So let's choose this one to be our 2. And then the other leg is still missing. We don't know what B is. So I'm just going to leave it as B to the power 2. And that's going to equal to the hypotenuse, which is the length of 10. From here, I'm just solving for B. So 2 to the power 2 equals to 4. Drop down the B square. 10 to the power 2, that equals to 100. From there, I'm going to get rid of the 4 so that I can isolate B by itself. If I do that, that means that I need to subtract 4 on both sides of the equation. So I subtract 4 on both sides of the equation and drop down the B square. I'm left with B squared equaling to 96. And then I want to get rid of the square, and the opposite of squaring is to square root on both sides of the equation. When I do that, I get B equaling to the square root of 96, which is 9.798. That would be my final answer. Okay. Let's look at the other diagram. The other diagram has A equaling to 5, B equals to 2, and we still need to use the formula leg squared plus the other leg squared equaling to the hypotenuse squared. So to do that, I need to identify what my hypotenuse is. Again, we want to look at the opposite side of the right angle, which is C. This would be our hypotenuse, and so it's telling us that the other sides here are our legs. This is a leg, this is a leg, and then from there I'm just plugging in my values. So one of the legs equals to 5, so I'm going to plug it in. We get here 5 squared plus the other leg, which is 2 squared. And the other one, we don't know what it is, so I'm just going to keep it as C squared. So right here, 5 to the power 2, that equals to 25. 2 to the power 2 equals to 4. And we have here C to the power 2. 25 plus 4 equals to 29. And that's supposed to equal to C squared. Again, I want to get rid of that square, so I'm going to square root on both sides of the equation. That way, I'm just left with C equaling to something. So C equals to square root of 29, which is 5.385. That would be my final answer. Okay. Alright, let me clear this. And last one is solving equations. We're asked to solve equations. So one of them is going to be adding or subtracting. The other one is multiplying or dividing. And the last one is solving equations that have fractions in them. So let's start off with the first one here. I'll give you a few minutes to try this out on your own. It's asking you to solve x plus 17 equaling to 20. Okay, so whenever we're solving equations, we always want to complete the opposite operation that's being shown here. It says that some unknown number is adding 17. So the opposite of adding 17 would be to subtract 17 on both sides of our equation. Remember, whatever I do to the left side of the equation, I have to also do to the right. So if I'm subtracting by 17 on the left, I have to subtract by 17 on the right side as well. If I do that, I'm going to drop down the x. 17 minus 17 equals to 0. And 20 minus 17 equals to 3. And so my answer here would be x is equal to 3. I'm going to do the same exact thing with the next problem. So right here, we have negative m being divided by 12. And that's equals to 2. Or you could see it as m being divided by negative 12. And so I'm going to write it down over here so I have more space. And I'm just going to rewrite it where the negative sign is on the bottom where the number is at. So since m is dividing by negative 12, the opposite operation of dividing is multiplying. So I'm going to multiply negative 12 on both sides. When I multiply negative 12 on both sides, that cancels out my negative 12, and I'm left with m equaling to 2 times negative 12, which is negative 24. Even if you're dealing with fractions, it's still the same type of system. So over here, again, whatever I do to the left side of the equation, I have to do to the right side of the equation. I see here that the variable is subtracting by 2 over 3. So the opposite operation would be to add 2 over 3 to both sides. If I'm adding 2 over 3 on both sides, I'm dropping down the a, and then right here we have 4 over 5 plus 2 over 3. Now since we have different denominators, that means that I need to multiply both sides by a number to make it the same denominator. And so let me make myself some more space here, adding the equal sign over here. And I'm going to multiply this side by the denominator of the right side, and I'm going to multiply this fraction by the denominator of the left side. If I do that, I have 3 times 5 and 5 times 3, or 3 times 5, and it's going to equal the same denominator. We get here 15, and this turns into a 12. Again, we have 15 now, and this turns into a 10. And so from there, since we have the same denominators, that means I can focus on combining the top. So 12 plus 10, that equals to 22, and the denominator stays the same. So we're left with a equaling to 22 over 15. Done. Okay. Alright, so hopefully this helps. Good luck.